Okay, so this is section 0.6. This is the last component of our math review that I'm wanting you all to go through, or that's particularly pertinent for this class. It's all about percentages, translate word problems involving percentages into mathematical equations. So percentage as a fraction of the whole. A percentage expresses the amount of a component within the total. The word per implies division, and cent means 100, so of 100 or divided by 100. So the word percent means divided by 100. Okay, so this right here shows a pie chart or a pie graph of the air in our atmosphere. 78% nitrogen, 21% oxygen, and 0.1% other, and 1% argon. That does have some chemical relevance, but not, well, don't worry about it for the time being. So percent in word problems, page 1 of 2. Percent, your mathematical translation, is going to be divided by 100. Of is going to be multiplication. What is generally going to be the unknown quantity, and is generally going to be what your equal. So an example of some of these word problems: what is 15% of 60? So basically what you would look at is this is a percentage, so you'd say 15 out of 100 times 60, the whole thing that we're trying to figure out. So what is 15% of 60? So we're taking 15%, and that of is we're multiplying it by 60. Now these aren't really key coded words or anything that you're going to be asked specifically about, but whenever you're processing this sort of information, being able to process it and figure out what the question is actually asking. So 8 is what percent of 40? Well, we're trying to figure out what percentage of 40 is. So we'd figure out that it's actually 20%. 2 is 25% of what number? Okay, so 2 is equal to 25%, or so 25 over 100 times x. And if you were playing along at home, you'd realize that that would be 8, and so you'd be good to go there. Okay, so an example sort of problem that you might come across in your homework or in a quiz or something like that would be this. Sucrose, also called table sugar, is 42.1% carbon by mass. So 42.1 divided by 100. If you had a 5-pound bag of sugar, how many pounds of carbon would it contain? Okay, so sucrose is 42% carbon. So a little bit less than half of the mass of sucrose is carbon. Now, if you had 5 pounds of it, well, what would you have? So you'd say 42.1 divided by 100 times 5. And on our next slide, it shows all that displayed. That would be 42 divided by 100 times 5 is 2.1 pound bag of carbon, or 2.1 pounds of carbon. Now, as you go through these sorts of things, I would argue that you're going to get, it's going to be helpful for you to get comfortable and it's going to be very comfortable and good for you to be able to transition and not even really worry about showing this. Instead, just saying 42.1%, well, that is 0.421 whenever I'm using it in a calculation. So I would say 0.421 times 5. That's effectively the exact same thing as this, but I didn't have to write out that division. And not having to do that division step is going to be kind of advantageous to you. Okay, so our last slide, percent as a conversion factor. A certain type of rock might be 25% iron by mass. In other words, there are 25 grams of iron in 100 grams of that rock. Okay, so what mass of iron is present in 72 grams of this rock? Okay, so you can think about that in terms of scaling. So if you have 100 grams of that rock, 25 grams is going to be iron. Well, you don't have 100 grams of it. You only have 72 grams of it. So basically what you can do is say 25 divided by 100 and multiply that by 72, and that comes out to be 18 grams. So it's effectively the same sort of thing, but it gives you quantities. So it says 25 grams of iron in 100 grams of this rock. And this is something that's going to be very helpful, or this sort of problem right here is going to be very helpful whenever we're talking about percent composition and elemental analysis. That's going to be, I think, in chapter number 3, 2 or 3. It's going to be kind of early, but it's just this sort of question. All right. Well, thank you very much, and I hope this is helpful.